Cutting wood? The journey of transforming a colossal tree trunk into usable lumber is a spectacle of power and precision, a dance between human ingenuity and the raw strength of nature. It begins with the arrival of a massive log, sometimes several feet in diameter and weighing many tons at the sawmill. This isn't your backyard DIY project with a handheld saw. This is industrial-scale wood processing, a domain where machinery of immense size and capability takes center stage. Before any cutting can commence, the log must be meticulously prepared. This initial stage is crucial for both the efficiency of the process and the quality of the final product. The log is first debarked, a process that strips away the outer layer of bark, dirt, and any embedded stones. This is often accomplished using a high-pressure water jet or a mechanical debarker with rotating blades. Removing the bark is essential as it prevents the saw blades from dulling prematurely and ensures a cleaner cut, free from imperfections that debris could cause. Following debarking, the log is scanned using advanced laser or X-ray technology. This digital mapping creates a three-dimensional model of the log, revealing its internal structure, including any knots, defects, or variations in density. This data is then fed into a computer system that calculates the most optimal cutting pattern to maximize the yield of high-quality lumber and minimize waste. This sophisticated planning phase ensures that every possible board, beam, and plank is extracted from the log, turning what was once a simple tree into a precisely calculated resource. Once the cutting pattern is determined, the log is maneuvered into position for the primary breakdown. This is where the head saw, the powerhouse of the sawmill, comes into play. There are several types of head saws, but two are most common for handling large logs: the bandsaw and the circular saw. An industrial bandsaw features a long, continuous band of toothed steel stretched over two large wheels, one powered and one idle. The log is secured onto a carriage that moves it back and forth past the rapidly moving blade. The operator, often situated in a climate-controlled cab with a clear view of the action, uses joystick controls to guide the carriage, following the computer-optimized cutting plan. Each pass of the carriage shaves off a thick slab known as a flitch, or cuts the log into large rectangular blocks called cants. The thinness of the bandsaw's blade or kerf is a significant advantage, as it creates less sawdust and thus wastes less wood compared to other saw types. The sheer size of these machines is awe-inspiring, with blades that can be dozens of feet long, capable of slicing through the densest hardwoods with relentless efficiency. The alternative, a large circular head saw, uses a massive toothed disc that can be several feet in diameter. While powerful and fast, its thicker blade produces more waste. After the initial breakdown at the head saw, the resulting cants and flitches are moved along a network of conveyor belts and rollers to the next stage of processing. This is where secondary saws, such as resaws and edgers, refine the lumber further. A resaw, which is often another bandsaw, but smaller than the head saw, is used to cut the thick cants into boards of specific thicknesses. The operator can adjust the distance between the blade and a guide, known as a fence, to produce lumber of precise dimensions, whether it be for construction, framing, flooring, or fine furniture. The flitches, which often have irregular rounded edges with remaining bark known as wane, are sent to an edger. An edger typically has multiple, repositionable circular saw blades that trim off the uneven edges, creating clean, straight-sided boards. Modern edgers are also often equipped with laser guides and scanners to help the operator align the cuts for maximum board width and minimal waste. The entire process is a symphony of automated movement in sharp steel, where each machine has a specific role in progressively shaping the raw wood. The air is filled with the high-pitched whine of spinning blades and the fresh, earthy scent of sawdust, a constant byproduct of this transformative process. Finally, the newly cut boards, now in their near-final dimensions, undergo the last steps of trimming and sorting before they are ready for drying and finishing. The boards are passed through a trimmer saw, which cuts them to standard commercial lengths, removing any split or defective ends. This machine usually consists of a series of circular saws, spaced at set intervals, which drop down to cut the boards as they pass underneath. Following trimming, the lumber is graded and sorted, This can be done manually by skilled inspectors who visually assess each board for knots, grain patterns, and other characteristics. Or it can be done by automated systems that use scanners and sensors to grade the wood based on pre-programmed quality standards. The sorted lumber is then stacked with spacers between each layer to allow for air circulation and moved to a kiln for drying. This controlled drying process reduces the moisture content of the wood, preventing it from warping or splitting later on. From a single monolithic log to a neatly stacked pile of dimensioned, graded lumber, the process is a testament to the power of industrial machinery. It is a precise, efficient, and surprisingly sophisticated operation that turns the giants of the forest into the essential building materials of our world.